This is the third video, students, continuation of the second video. So in this we are going to see the preparation of aldehydes and ketones. Okay, so first we are going to see oxidation and catalytic dehydrogenation of alcohols. So this reactions we have already seen in your hydroxy lesson, 11th chapter we have seen. Okay, so first is you must know that primary alcohol, when they are oxidized they give aldehydes. Secondary alcohols, when they are oxidized they give ketone. So in presence of oxidizing agent like sodium chromate crystals or potassium permanganate or PCC, but in the presence of this both um, sodium chromate crystals and potassium permanganate, this primary and secondary alcohol gives carboxylic acid. That is, first the primary alcohols will be converted into aldehyde group, and further oxidation it gives carboxylic acid. Similarly, the secondary alcohols also will be oxidized to ketone, and then on further oxidation they give carboxylic acid. This reaction is clearly given in the hydroxy lesson. If you want, you can go and refer there. Okay, oxidations of alcohols is they are given there. But when you are using this PCC as an reagent or oxidizing reagent, that time the reaction will be stopped here itself. Primary alcohols will be converted into aldehyde. That's all. Further oxidation does not take place. So if you want aldehyde as a product, you have to use only this PCC as the oxidizing agent. Okay, so the first preparation is this. So second is when you are passing the vapors, alcohol vapors, through the metals of copper and silver. Okay, in the presence of the metal copper and silver, if you're passing the vapors of alcohol, the reaction takes place and you get an aldehydes and ketone as the product. So this is the catalytic dehydrogenation process. Okay, so this is also clearly explained in your 11th chapter. You can go and refer there. If you have any doubt, you can ask me. Okay, so the second one is the important question, that is ozonolysis of alkenes. So if you subject these alkenes to the process of ozonolysis, you get aldehydes and ketones. Okay, that we'll see now. So first they have taken any alkene. You can take alkene means they must have a double bond, that you have to remember. So they have taken here as a butene. Butene they have taken, and they are subjecting to the process of ozonolysis. That is, O3 is passed over there. So whatever reaction is going to take place, it takes place only across a double bond. Okay, so here the double bond breaks and the oxygen goes, one oxygen goes and occupies bonds a bond at the top and the others in the bottom. So it forms an ozonoid. The structure of this is an ozonoid. Okay, so it is highly unstable. So the bond cleavage occurs when you are passing the zinc dust over it. Okay, over it, the cleavage happens like this, and you get two molecules, CH3CHO and CH3CHO. So two molecules of CH3CHO you get, plus hydrogen peroxide. So name of this is ethanol. Since you have two carbon atoms and an aldehyde group is present, you say it as ethanol. Then second, you are going to see about another compound, that is 2-methyl butene. So I am going to add one methyl group to that, to this carbon. So it was the same reaction. So O3 is passed over it. Then the same here, and the bond will be formed like this between this carbon. Across a double bond only reaction takes place. Similarly, the first one oxygen will be forming a bond at the top, the other two at the bottom. It forms an ozonoid. The cleavage happens like this. When you are passing the zinc dust, then you get one CH3CHO, that is ethanol, and here CH3COCH3. So two aryl groups are present. So you say it as in ketone groups. Propanone, 3 carbon is present, so propanone plus hydrogen peroxide, H2O2. Understood, students? If you have any doubt, you can ask me. Okay, so if you want formaldehyde as a product, you have to use olefins. Okay, if you use olefins, you will get olefins are nothing but the alkenes. Okay, if you use terminal alkenes, that is smaller alkene, you get the formaldehyde. Here we have used butene, no. So instead of long chain, if you used short chain, that means carbon with one carbon, you will get this formaldehyde as a product. Okay, so next is the hydration of alkynes. So alkynes means, when you see the word alkynes, you should remember that it is a triple bond. So you're going to write a you're going to prepare this aldehydes or ketones from an triple bond compound. Okay, so you can write any compound having triple bond. They have given here as ethine. Okay, plus see, it is hydration. Okay, it is a hydration reaction. Hydration means addition of water. So water, they have H2O is a water, it will be splitting as H plus and OH minus. That only they have written like this. So this reaction is taking place in the presence of concentrated sulfuric acid and mercury sulfate. So in that we are going to get 40% of sulfuric acid and 1% of mercuric sulfate only are going to take. So what does it happens is, this O goes and attached to this carbon, and this OH goes and attached to this carbon. So since it is an OH group is present, functional group, you say it is an alcoholic, right? So you generally, if you want, you can write the name, IUPAC name, but they generally you represent as enol because it is highly unstable. They isomerize to form a stable compound. So you refer it as enol. So it is enol. Since it is a double bond, you say ene. If it is a single bond, anol. So it is a double bond, right? So enol. Single bond means anol. So double bond, alcohol. So enol, it isomerizes to form a CH. It isomerizes, the carbon stabilizes to form CH3 CHO. So ethanol. The common name is acetaldehyde for this. Okay. So similarly, this ethane, you can refer it as acetylene. Okay, so how will you prepare acetaldehyde from acetylene? Also this reaction only you have to write. Okay, so the second one is that if you are using acetylene only, you will get this aldehydes. In alkynes, this acetylene only gives this aldehyde group. So other than acetylene, whatever alkyne you are taking, they give only ketone as the product. So they have taken here as prop 1-ene. See, 3 carbons of prop. First carbon only triple bond is there, so 1-ene plus the same hydration reaction, the presence of mercury sulfate and sulfuric acid, the same will be there. Hydrogen goes and attached to this carbon, and the hydrogen goes and attached to this carbon, and OH attached to this carbon, you get an enol. So it isomerizes to give what, CH3, C double bond O, this H comes and attach here, so it is CH3. Okay, it is propanone. Okay, I hope you understood, students. If you have any doubt, you can ask me. Okay, so the fourth one is preparation from calcium salts, okay, of carboxylic acid. So carboxylic acids, calcium salts only, we are going to prepare this aldehyde. First you are going to see preparation of aldehyde alone. So you are going to take calcium methanate. Methanate means 1 carbon, so you are getting 2 molecules of calcium methanate you are going to take. Methanate means O group is O8. Okay, so oxygen will be present. So calcium, it is attached to 2 methyl group. Okay, so CH, carboxylic acid means it is an COOH, right? So COOH, one calcium, COOH, calcium, calcium methanate group. When it is subject to the process of dry distillation, the cleavage happens. CaCO3 you write first, CaCO3. So if CaCO3 goes, remaining is HCHO. So it is methanol. Methanol is IUPAC name. Common name is formaldehyde. So they can ask, how is formaldehyde prepared from the carboxylic acids? So you can write this as the reaction. So second is, they are going to take calcium ethonate and calcium methanate. So here ethyl group, ethyl means 2 carbon will be present. So here only 1 carbon we have written, no? So you are going to write another 1 carbon, CH3 group. So it is calcium ethonate plus calcium methanate. So this is a methanate, so this is ethonate. So the same process, you get one aldehyde, and it is CH3. See, same way you write CaCO3, CaCO3. So you get CaCO3. Okay, so you get 2 molecules of CaCO3, then rest you get CH3, 2 molecules of CH3 CHO. So it is nothing but ethanol, or you can write it as acetaldehyde. Okay, so the common name is acetaldehyde. You can refer it as acetaldehyde. So they may ask, how is acetaldehyde prepared from the calcium salts of carboxylic acids? That time you can write this reaction. Okay, so if you cleanly you see this reaction, you understood the reaction. If you cleanly notice, you can understand. So you have that calcium carbonate is removed. So once you remove this calcium carbonate, the rest will be the product. Okay, so the second one is the ketones. So these two are the formation of aldehydes we have seen. Second, we have to see the preparation of ketone from this calcium salts of carboxylic acid. So here I am going to get calcium ethonate. See here I have taken calcium ethonate. Here I am going to take calcium ethonate since I need one CH3 group there. So dry distillation, same process. You get here, see here, I said no. Carbonyl aldehyde means they have a H group, and the ketone means they have a CH3 group. So I am going to replace one H by CH3 group. So I get CH3 double bond O CH3. It is propanone plus calcium carbonate. See here, ethonate means two carbons. So CH3 COOCA. H will be replaced by Ca. That is the calcium ethonate group, right? CH3 COOCA. CH3 COOCA. So both will be the CO3 group will be removed. CaCO3 group will be removed. So if you remove, you get CH3 COCH3. So it is propanone. So the common name is acetone. So how is acetone prepared? So this is the process. So they may twist the question also and ask students. So you have to learn. So this is formaldehyde, this is acetaldehyde, this is the acetone. So this is an important preparation. They may ask you directly or indirectly, you must be able to answer. So if you're not able to understand these reactions, you can ask me, I'll explain it again to you. Okay, I hope you all listened, you all understood. If you understood only, you can study organic chemistry. Other than that, you will not understand. Okay students, but I'm ready to explain to you n number of times, but you have to come out to me and I ask. Okay, I hope you understand. Okay. Okay students, so next class we'll see. Thank you.